Good Wednesday morning. It's March 24th, 2021. I'm Guy McPherson of Nature Bats Last. You can find Nature Bats Last at guymcpherson.com. This science update focuses on how absolutely stunningly lucky we are at the level of our planet, at the level of the universe, at the level of us as individuals. I frequently cite evolutionary biologist from Britain, Richard Dawkins, with respect to the improbability of DNA coming together to form each of us as unique individuals. And he wrote, "In the teeth of these stupefying odds, it is you and I that are privileged to be here, privileged with eyes to see where we are and brains to wonder why." That's beautiful. And yet here we are against stunningly improbable odds, which were pointed out again to me by a paper in SciTech Daily. SciTech Daily is one of the sources that attempts to make scientific information accessible to lay people. So it's a simplification of peer-reviewed articles. This one comes from the University of Southampton on February 28th, 2021. And here's the lead. A study by the University of Southampton gives a new perspective on why our planet has managed to stay habitable for billions of years, concluding it is almost certainly due, at least in part, to luck. The research suggests this may lengthen the odds of finding life on so-called twin Earths in the universe. So, suggesting, again, the improbability of us existing at all in this physical form. And yet, here we are. The situation is precariously balanced, the paper goes on. A continuously stable and habitable climate on Earth is quite puzzling. Our neighbors, Mars and Venus, do not have habitable temperatures, even though Mars once did. Earth not only has a habitable temperature today, but has kept this at all times across 3 to 4 billion years, an extraordinary span of geological time. That, according to the author of this paper, the one author of this paper, Toby Tyrrell, a specialist in Earth system science at the University of Southampton. The paper at SciTech goes on. The results were very clear. Out of a total population of 100,000 planets, 9% were successful at least once. Of those, nearly all, about 8,000 of the 8,700, were successful fewer than 50 times out of 100, and most, about 4,500 of the 8,700, were successful fewer than 10 times out of 100. To put it another way, if an intelligent observer had been present on the early Earth as life first evolved and was able to calculate the chances of the planet staying habitable for the next several billion years, the calculation may well have revealed very poor odds. The peer-reviewed paper was published in Communications, Earth and Environment on December 11th, 2020, and the abstract is particularly compelling. Earth's climate has remained continuously habitable throughout 3 or 4 billion years. This presents a puzzle, sometimes called the habitability problem, because loss of habitability appears to have been more likely. Solar luminosity has increased by 30% over this time, which would, if not counteracted, have caused sterility. Planet sterility doesn't sound like a good thing to me. Continuing in the abstract, furthermore, Earth's climate is precariously balanced, potentially able to deteriorate to deep frozen conditions within as little as 1 million years. Here I present results from a novel simulation in which thousands of planets were assigned randomly generated climate feedbacks. Each planetary setup was tested to see if it remained habitable over a period of 3 billion years. The conventional view attributes Earth's extended habitability solely to stabilizing mechanisms, such as, for example, the Gaia hypothesis. The simulation results shown here reveal instead that chance also plays a role in habitability outcomes. Earth's long-lasting habitability was therefore most likely a contingent rather than an inevitable outcome. We got lucky. Elsewhere in the paper, from early on, that habitability may be precarious was also emphasized in the 1990s by theoretical calculations showing Earth's considerable potential for climate variability. And here he cites other people's work. After the realization that neither Mars nor Venus presently have temperatures conducive to life, and that Earth's carbon dioxide greenhouse is potentially unstable, two main classes of solution were advanced to try and answer the habitability problem for Earth. The first class involves stabilizing mechanisms. Earth must possess an inbuilt thermostat and have possessed it since its early history. Otherwise, climate would have followed a random walk with an impossibly small likelihood of remaining within habitable bounds. One proposal in this class, the Gaia hypothesis, suggests that once life becomes established on a planet, then it intervenes in climate regulation to keep conditions stable and habitable. However, the Gaia hypothesis lacks a clear mechanistic basis and is not consistent with the most recent scientific evidence. And either of those is enough to draw serious questions about the Gaia hypothesis. A second very different class of solution has also been put forward based on the principle of observer selection, what's called the weak anthropic principle. Logically, we can only ever observe facts that are consistent with our own existence. And so this can be extended to the idea that the most widely held view at this time is that Earth has been a habitable planet for billions of years because of the existence of stabilizing feedbacks on the global carbon and silicon cycles. Although there are a few exceptions, the possible role of chance is typically not even mentioned in these previous papers. Here I describe a new model of habitability and report its results. The results suggest strongly that chance also played a role. So that's a very interesting outcome. The discussion begins with this sentence: the obvious implication from these results is that Earth's success was not an inevitable outcome, but rather was contingent. It could have gone either way. That's a direct quote from the paper. So there you have it. We got lucky. We continue to get lucky. We're here for another day. We have not pushed the planet beyond habitability. And that's pretty stunning considering how profoundly we have changed Earth's atmosphere. Thank you for staying tuned. Please look forward to another one of these science updates in the not too distant future.